Hey guys, welcome to the very first section of Algebra 2. We're going to be starting with section 1, representing functions. Our very first vocab word is an ordered pair. An ordered pair is just the coordinates of a point, and the coordinates go x, y in alphabetical order. X, y, it's very important. Next is the Cartesian coordinate plane. The Cartesian coordinate plane is broken up into 4 quadrants, starting in the upper right and then going counterclockwise. 1, 2, 3, and 4. We're going to place these points in the Cartesian coordinate plane, and the first one is -4, 2. Remember, it goes x, y, and so it's going to go x is in the -4, and then we have to go up 2 for the y, so it's going to be -4, 2. This guy has a positive x and a positive y, so it's going to go 3 and then up 2. Now, our x's in quadrant 1 will be positive. Our y's will still be positive. In quadrant 2 now, our x, though, is, if we look on our plane, it's negative, and our y's are positive. X is here in quadrant 3, still negative, but now our y's are negative, and our x's here in quadrant 4, positive and negative. Next, a relation, another vocab word, is a set of ordered pairs. So here would be a relation 1, 2, remember it goes x, y, -4, 5, or you can pick any other point and fill it in. You could have 9, 10, you could have -9, -10. Any point would be a relation. So now, mapping shows how each member of the domain is paired with each member of the range. And now if we forget what domain and range mean, that's right. Our domain is the x values, and the range is our y values. So here, that 1 would be a domain, and the 2 would be, the y would be the range. So here is our domain, and here is our range. So a mapping would show 1 to 2. So this 2 belongs to 1, -4 to 5, and then the only thing left here is this 3 to 7. Over here we have 8 to -4, so 8 to -4. We have -3 to 9 already drawn in. We have 1 to 2, and also 8 to 5. Now check out this 8 real quick. It's going to come up on the next slide. We have it going 8 to -4 and 8 to 5. Next, this is just the 4 different ways that we can represent a relation. We can have it in ordered pairs, we can have it in a table, we can have it in a graph, or we can have it in mapping. We can represent the relation in 4 different ways: ordered pairs, tables, graphing, and mapping. Now, a function is a little bit different than a relation. A function is a relation in where each element of the domain, so each x, is paired with exactly one element in the range, has one y belonging to one x. So if we were to graph this relation, we have 8, 1, so we go over 8 on our x first. Right here, there's 8, and then up 1. So we put a point. Then 4, 2. So we go over 4, down 2, put a point. 1, 1, put a point. -3, up 2, put a point. And -6, down 8. 8, close enough. And now, is this relation, we know it's a relation because we graphed it, but is it a function? Is there any x value that has more than one y value? And if we look at all our x values, they just have one y value, so yes, this is a function. We can look at functions a little bit differently too. If we look at functions where we put the x in, we can look at a function as a machine. So we have x, y, So I'm going to put my x in the machine. It's going to go through the machine, and it's going to give me a 2. Or if I put a 2 in the machine, it's going to spit out a 3. Each different x I put in is going to give me a y value. I'm not going to put in 1x. Say if I put in a 1 here, I'm not going to get a 3. I can only get a 2. So if I put in, let's go to not a function. If I put in a 1, it goes through the machine and it gives me a 2. But now we have this guy where if I put in a 1, it goes through the machine and it gives me a 3. This is not a function because I have two different y values. Those are my 2 and my 3 are my y values. Those two guys right there belong to the same x value. So I cannot have, one more time, I cannot have two different y values for one x value. If we go back to our example, which has disappeared on me, if I go back to my mapping example, this would be a function because there is one y value for an x. There is not more than one y for one x. If I go over here, notice my 8. My 8 goes to two different y's, so therefore this is not a function. Now, what if I had another number? Let's just make it 4. It could be any number, just sitting in my domain. This 4 does not have to go to any number for a mapping. That's fine. It would still be a function. But that concludes it for the first section of Algebra 2.